Hello children, today we are continuing with chapter 4, light, and today we are doing part 3, that is we are discussing the nature and component of light. So, the first characteristics or the nature of light we want to discuss is the speed of light. First of all, light it travels in a straight line. So, to prove this, what we can do is we can take two cardboard pieces with tiny holes in them, and on one side we can place a burning candle as a source of light, and on the other end we can place an eye in which we can see right through the two holes that we have made, and this is the line of sight, and you can see that as it's passing through the two holes, and we are able to see the candle. The light from the candle passes through the holes and reaches the eye. So supposing if we shift this cardboard up so that the hole appears here and this portion gets blocked, the light will get stopped right here and the light will not be able to reach our eye. Now the light is not going to bend and get into our eye like this. The light is traveling in a straight line, so if there is anything that is blocking the path, the light will not be able to pass through. So this experiment proves that light travels in a straight line. Second is, it does not require a material medium. It does not require a material medium means it can travel in space, it can travel in vacuum, it can travel in air, it can travel through liquid, transparent liquid. Unlike sound, sound requires a material medium. Sound requires either a solid state or liquid state or a gaseous state for it to pass through. But light does not require any one of them. It can even pass through vacuum. So light can travel through vacuum also. So this is the reason why we receive the light from the sun, is because light can travel through vacuum in space and it reaches us. If light required medium, then the light from the sun would not have reached the earth. So this proves that light can travel through vacuum. The speed of light is very fast. Okay, the speed of light is it's 300,000 kilometers per second. Now this can be also written as 300 million meters per second, and in short this can be written as 3 into 10 to the power 8 meters per second. So you can see that light can travel very fast. In 1 second it can travel 300,000 kilometers, which is really fast. Now this is the speed of light in vacuum. When light has to travel through other mediums, light slows down a bit. Like for example, if light has to travel through water, the speed of light slows down a bit, and the speed of light becomes 2.25 into 10 to the power 8 meters per second. You can see that the speed of light is 3 into 10 to the power 8 meters per second, and it becomes 2.25 into 10 to the power 8 in water. In alcohol, the speed of light becomes 2.20 into 10 to the power 8 meters per second. So this is the discussion with regards to the speed of light. First of all, light travels in a straight line. It does not require a material medium. It can travel through vacuum also. The speed of light is 300,000 kilometers per second, which you can short form, you can write 310 to the power 8 meter per second. And light, when it travels through material mediums, like for example water, it slows down and travels at a speed of 2.25 into 10 to the power 8 meter per second. In alcohol, it travels at a speed of 2.20 into 10 to the power 8 meter per second. Now let's discuss about color of an object. As you know, if you have an object, okay, and the white light falls on it, you are able to see this object because this object reflects the light into your eye, okay, and we are able to see this object. Now, some objects have colors, and we are able to see the color of the object because the object reflects a particular color of light. Let's say white light is shining on this, and if this object reflects the red color, then this object will appear red to us. Next, let's discuss about the components of white light. As you must have seen a natural phenomenon called a rainbow. So that basically proves to us that white light basically consists of many colors, many component colors, and the colors that you see in the rainbow is normally comes in this format: VIVVYOR. So V stands for violet. I stands for indigo, D stands for blue, G stands for green, Y stands for yellow, O stands for orange, and R stands for red. So white light breaks up into these component colors. So it proves that white light just isn't white, it consists of these 7 colors. And out of these 7 colors, we'll be discussing next the color red, the color green, and the color blue. These 3 are called the primary colors. So once again, the components of white light are these 7 colors. You must have seen this phenomenon when you observe rainbow. So the colors are, in remember short like this: VIVGYOR. Remember it's mnemonic, it is easy to remember. So violet, indigo, blue, green, yellow, orange, and red. Out of which blue, green, and red, these are called the primary colors. Now, the definition of primary colors is that these primary colors cannot be obtained by mixing any other color. That means you cannot mix any other color and get the primary colors, and as we just told you before, the primary colors are red, green, and blue. And the primary colors are green and blue. So any other color that you will see are a mixture of red, green, and blue, and the proportion of this red, green, and blue changes, and depending on the different proportion of red, green and blue colors, you will get different colors. So when you mix all these three red, green and blue colors in equal proportion, you will get back the white light. So once again, primary colors are colors that cannot be obtained by mixing any other color. So the primary colors are red, green and blue. Any other color that you see is always a mixture of these three colors in different proportions, and if you mix the red, green and blue colors together, you will get back the white light. After primary colors, we will discuss about secondary colors. Now, secondary colors are colors which are obtained by mixing two primary colors of equal proportions. So, so secondary colors are produced when two primary colors are mixed in equal proportion, and they are also called composite colors. And these are the colors, these are secondary colors. They are yellow, and you will get yellow when you mix the two primary colors red and green. The next secondary color is cyan, and you will get cyan if you mix the two primary colors blue and green. And the last one is magenta. You will get magenta when you mix the two primary colors red and blue. So once again, secondary colors are produced when two primary colors are mixed together in equal proportions. Secondly, it's also called a composite color. And these are the three primary colors. These are the three secondary colors. The first color is yellow. You will get yellow when you mix red and green. You will get cyan when you mix blue and green. You will get magenta when you mix red and blue. Next, let's discuss about complementary colors. Now, complementary colors are colors which, if you mix together, you will get white color. So, and it's actually two colors. Two colors will mix together when you produce a white color. And the following are the complementary colors. If you mix the color green and magenta, you will get back a white color. If you mix blue and yellow, you will get again white color. If you mix red and cyan, you will get back white color again. So why do we get back white color? This is because green is the primary color and this magenta is actually a mixture of two colors. If you remember, magenta consists of two colors, is red plus blue. So essentially, when you mix a primary color with a secondary color, you are actually putting all the three colors together, which obviously will give you white, as I told you before. So green plus magenta is actually green plus red plus blue, which will give you white. In the same way, blue plus yellow is actually a mixture of red and green. So blue plus red plus green will give you white. And red plus cyan, that means red plus cyan is a mixture of blue and green, which will give you white. So this is how we get a complementary colors.